Okay, let's try to understand how do metals behave when they come in contact with the acids, or how metals react with acids. So what is an acid, right? So definition is acid is something which can react with the base to form solid water. That is the basic definition that we have learned. Or acid is something which can turn the blue litmus paper red. Any solution of a compound which can turn a blue litmus paper red is an acid. A compound that can react with the base to form salt and water is an acid. But when you go up, when you become and in a higher classes, it is also defined as a compound containing hydrogen and which has the ability to release the hydrogen ion, which is also known as proton, as a substance which is able to give away its hydrogen ion. It's known as an acid. So HCl, hydrogen chloride, or hydrochloric acid. We're taking dilute hydrochloric acid. DIL represents dilute. There's a lot of water. A lot of water is used to make this solution, because the concentrated hydrochloric acid, which contains only hydrochloric acid without any water, is quite dangerous to handle in a laboratory. So we generally in a laboratory use dilute hydrochloric acid. So what we have a statement is that what the textbook is saying is that metals react with dilute acid to form salt and hydrogen. And where does this hydrogen has come? It has come from the acid. Whatever the hydrogen the acid whatever hydrogen the acid has, it has been replaced by the metal, forming a salt, and hydrogen that isn't released forms a gas. Hydrogen gas is formed. So for example, if you have magnesium, aluminum, zinc, or iron, these are all metals. These are the example of metals, and when they react with dilute hydrochloric acid, obviously, as per the statement, a salt is supposed to be formed and hydrogen gas will be released. The textbook says you to find that to write the chemical equation, balance the chemical equation. You'll find that there will be formation of salt as well as hydrogen. I have not written the hydrogen, just the salt part I have written. For example, magnesium plus dilute hydrochloric acid will form magnesium chloride plus hydrogen, and aluminum plus dilute hydrochloric acid will form aluminum chloride plus hydrogen. Zinc plus hydrochloric acid will form zinc chloride plus hydrogen, and iron plus dilute hydrochloric acid will form iron chloride plus hydrogen. So these are the salt, and hydrogen is formed. What about the formula? How do you know the formula? In order to know the formula of magnesium chloride, what you need to know is you need to know the valency of magnesium chloride. The valency of chloride is 1. So 1 will be written here and 2 will be crossed. The valencies will be crossed, right? So Mg is 2, valency of 2 magnesium is written here, and valency of chlorine is written here. It gets crossed. This is how we write the formula of a compound. So what is aluminum? How is aluminum chloride written? Aluminium's valency is 3, chloride valency is 1, aluminum chloride. Zinc's valency is 2. Then you need to remember iron. It can have both the valency of 2 and 3. So whatever the salt is formed, it may be either FeCl2 or FeCl3 depending upon the valency of the iron. Now, then there will be hydrogen on the right. Then one more product will be there. It will be the hydrogen. And what you need to know, we need to do is you need to balance the chemical equation. For example, here there are 2 hydrogen atoms on the right side. I haven't written the hydrogen. So there will be 2 hydrogen atoms. To balance it, write 2 before this. In that way, you have balanced hydrogen atom. In doing so, number of chlorine atoms will be 2. So there are 2 chlorine atoms on the right side and 2 chlorine atoms on the left side. Next, what happens when a metal reacts with nitric acid? So this is also an acid. Suppose this is dilute nitric acid. What happens? According to this statement, when metal reacts with an acid, there should be formation of salt and hydrogen, right? But there's a slight the change in the product that is formed. What happens is, although a salt is formed, hydrogen will be oxidized by the nitric acid. Whatever hydrogen form, it will further react with nitric acid to form water. It is called like oxidizing. Nitric acid is a very strong oxidizing agent. I'm writing here oxidizing, OXIDISIN, the oxidizing agent. Right? It oxidizes the other compound, and so it supplies oxygen. So hydrogen is supplied oxygen by the nitric acid. So the hydrogen becomes water. So hydrogen is oxidized to water by the nitric acid. And what happens on nitric acid? It itself gets reduced. Reduced, it gives out the hydrogen. So whatever hydrogen is given out. So what is formed? It forms various oxides of nitrogen. It may be nitrogen dioxide, nitrous oxide, or nitric oxide, or a mixture of all the three. So this is how nitric acid. So the difference is that generally when metal reacts with any dilute acid, there is a formation of salt and hydrogen, right? But in case of nitric acid, there is no formation of hydrogen, because of whatever hydrogen is formed, it's been oxidized by the nitric acid to form water, and various nitrogen oxides are formed. So we find that not all the metals they react in the same way with acid. Some of them are very reactive and some of them are not. So we find that there's a reactivity series. Like magnesium is out of these elements, magnesium is one of the most reactive elements. So magnesium is more reactive than aluminium. Aluminium is more reactive than zinc, and zinc is more reactive than iron. Although there is no proper way of uh, of learning, or you need to by heart this, there's no particular rule how to know how why this is more reactive than this, or this is more reactive than this. That will be learned in your higher classes, but for the timing you just need to memorize that magnesium is more reactive than aluminum than zinc, and the zinc is more reactive than iron in this way. But what about copper? When we put copper in a dilute hydrochloric acid, we see that there is no formation of the bubbles. In our earlier class, we find that metals, when they react with water, maybe cold water, some react very vigorously with cold water, some react with hot water, and some react with steam. But we find that then this copper when react we find and we also knew that when hydrogen gas is formed, when the metal reacts with water, that hydrogen comes out as you can see the bubbles coming out, and because when those bubbles they cover up the metal, and because of that the metal floats above. It no longer reacts with the water. So, and what I mean is that formation of hydrogen gas is like it means that there's the reactants are reacting with one another. But when copper is meant to react with dilute hydrochloric acid, we find that there are no bubbles formed. That means no hydrogen gas is formed, and there's no change in temperature. It's not an exothermic reaction. That means copper is not reacting with dilute hydrochloric acid. So what we have understood is that this particular statement, which says that metal when reacts with dilute acid forms salt and water hydrogen, is not always true, because so we find that this particular metal, copper is a metal, and so it's not reacting with dilute hydrochloric acid, right? I hope this is you are able to understand the things, how metals react with acids.